Good afternoon, everybody, and welcome to the Power to X to Power webinar, which is part of the Energy Vasa Talk webinar series. My name is Suvi Karirinne. I work in the University of Vasa as a director of Vasa Energy Business Innovation Center, and I will be your moderator of this webinar. So, Power to X to Power certainly is an interesting topic, and with me, there are 4 experts to give us light what is happening in the interesting field of technology. So let me introduce to you Jukka Lehtonen, who is the Vice President of Technology and Product Management in Wärtsilä Energy. Erik Jungner is also coming from Wärtsilä, and he is a Director of Product Management. Niko Paaso is the Vice President of the Power Division in EPV Energy. And last but definitely not the least, there's Hans Alexander Öst, who is the Director of Development in Vasa and SAC. So nice to meet you all. Of course, the speakers as well as the audience behind all the screens. So let's start the webinar now. So the name of the technology, Poverty Acts to Power, sounds more like name of the robot in a Star Wars movie or a Marvel superhero than an energy technology solution. Our first speaker, Jukka Lehtonen, will elaborate a bit what lies behind the name and why it is important to develop these new Power to X to Power solutions and technologies. So please, Jukka, stage is yours.
Thank you very much, and hello everybody. It's a pleasure being here with you. And definitely this is an extremely interesting subject for our future and needs a huge amount of attention for all of us. It definitely, the name Power to XX to Power is like a Star Wars scene in that sense, or name, but behind that one, we have power that needs to be turned to some kind of some sort of midterm storage, and after that one, later on, it has to be turned into electricity again. So when we are looking at path to 100% renewable energy, with the next slide, there's a small illustration that where we are today and where we should be going. And when we think about that one, the reality today is that renewables are getting cheap. When we reach the tipping point that the existing thermal capacity is replaced by flexible generation, then we start moving towards more and more need to store the energy from the renewables. When the renewables are base load, then we have the location where we are less dependent on the current energy production systems, like coal, for example. Then at that point, we need to have the balancing services. And if we want to have that those balancing services with the renewable energy, that renewable energy have to be stored. And there we come to the phase that it's stored to different forms of energy. Is it then hydrogen, or after that one synthetic gases that are then coming from the hydrogen? But what we need to remember is that hydrogen needs to be produced from the renewable electricity. So hence it comes down from power to hydrogen, for example, and then from hydrogen to power again. So it is in a way a storage in the middle for the energy. Then on the next slide, I would like to talk a little bit about, in that sense, that hydrogen is one of our key ingredients for the renewable future, because that's the raw material to produce the power, or raw material to produce future fuels, which are then the synthetic fuels. And at that point, we need to then consider that what kind of infrastructure we have and where do we go, where we do our investments with the infrastructures. And when we think about that, how much of energy is needed for the renewable energy future, based on our calculations today, we are looking at 900 gigawatts needed for renewable power. So we are in a quite early stages still, but we are in a good speed towards the future possible renewable energy infrastructure. Sorry.
Okay. So, because when we talk about hydrogen, and we usually talk about hydrogen economy, the discussion about hydrogen and hydrogen economy, it already have started like from 1960s. And its role in the conversation and policies concerning this kind of sustainable development and transition towards sustainable development and the need of it has increased quite recently. And as you showed in your presentation, the potential for hydrogen in the energy transition from fossil-based fuels into zero-emission ones is significant. So what do you think are the main reasons, what they have been for the slow development of this hydrogen usage as a fuel and the development of the hydrogen economy?
That's an extremely good question. For the green development, it has been that hydrogen has been produced and still is today. Over 95% of the hydrogen is produced from the fossil fuels. So for the green future, we need to have the renewables producing the hydrogen, and then it would be a green hydrogen, and in that sense, helping for our decarbonization needs. And when considering why it hasn't come up earlier, it has been looked at, developed, but not in a big ways, is that it's extremely expensive to do, and technology for storing hydrogen is not simple and in a way economically feasible. But with the current developments, I'm sure that there will be great leaps forward with the technologies. But at the moment still, we are looking at quite a beginning of the era for hydrogen technologies.
Okay, thank you. And another question, because as you said, the need of fossil-free energy and this kind of green energy is huge in the future if we want to do this decarbonization. The global energy consumption has been increasing quite steadily for the 20th century, and it has been estimated to be increasing for the 21st century. Within this total primary energy demand, the fossil fuels are expected to possess more than one half, and the situation is estimated to be the same until 2040. So one solution to the problem, okay, it's hydrogen, but then again, increasing the renewable energy production. So Jukka, what are these renewable energy technologies you consider to be the most promising ones, taking into consideration the scale needed for the energy production's decarbonization?
That's extremely valid question, what those could be. We cannot have enough water stored everywhere. I would say right away that it would be wind and solar. Those are the two most promising ones and economically most feasible ones to be the sources for the renewable power, definitely.
Okay, thank you, Jukka, and thank you for your presentation. And now actually we're going to switch to the second presentation coming from Wärtsilä, from Erik Jungner. So I will start this with the question that Jukka showed that, okay, we are transitioning towards hydrogen as a fuel. So there are quite vast number of vessels in the world's seas and engines, large engine using diesel oil as they fuel in. And is there a future, Erik, for these engines? Are they going to be buried in the engine cemetery? So please elaborate us.
Thank you, Suvi, and really happy to be here also. Actually, I hear your question loud and clear, and why on earth would you actually think of a diesel engine or something that was invented 120 years ago? Actually, even more would have anything to do with a sustainable and renewable future. That is something we need to ask ourselves now and then. But at the same time, we would need to take another look at it as well, and considering what kind of milestones the engine technology has been walking through in order to be successful through all these years, and looking at it from that angle, we have strong reasons to believe that it also will succeed in a 100% renewable world. And in order to aid a little bit my answer to your question, I would be happy to walk you through a short presentation as well on this topic. And now we would be focusing mainly then on the X to power part of this topic. So if you could swap to the next, and then again the next slide, please. Yeah. They actually say that you are what you eat, right? And if we look at the combustion engine itself, it would be fair to name it as a true omnivore in that sense, because if we walk ourselves 45-50 years back, it actually made quite some breakthrough in especially marine side, but also in land-based energy production, when the medium speed engine was there to take heavy fuel oil as the fuel, which in fact was by far the most competitive fuel at that time. That actually also was a kind of a trigger for Wärtsilä also to start building up its power plant business a couple of years later. 20 years later, there was another remarkable milestone in its history, because then industry scale operation on natural gas was possible with the very same technology platform. If we compare already heavy fuel oil in an engine compared to coal power, that's already half of the carbon dioxide emissions. And when switching again to natural gas from heavy fuel oil, a further reduction of 25% could be seen. So that was a remarkable step in the right direction. 20 years later, after that one, we started already to see some initial indications from the market that customers were interested in. There was already small scale hydrogen available, and we got the question that, hey, can we blend in hydrogen into the natural gas, and will it work in our technology? And actually, why it was asked for the 25% and not more is that there are the safety standards typically classify up to 25% of hydrogen in natural gas as natural gas, meaning that you can use the same equipment and apply the same safety practices as well. And of course, with this step, blending in a fuel without carbon content, that would further decrease the carbon footprint of the total operations, of course. Now we are actually standing in front of the next major milestone, which is the step to pure carbon-free fuel, and we are actually gearing up our R&D efforts here now to do the first tests on pure hydrogen. If I could ask for the next slide, please. And even though I just told you that it was 5 years ago when we did the first initial testing, our research in hydrogen goes actually way more back in the history, and 20 years is actually pretty spot on, because in September 2001 was the very first R&D project kickoff meeting for hydrogen as a fuel. But the case was very different at that time, because it was about electrolyzing water into oxygen and hydrogen, but oxygen was the desired deliverable from that process, and hydrogen was more of a rest product. And we were asked that hey, can we use this one in our equipment? And so the case was definitely different, but after all, it never materialized. Can I have the next slide, please? Yeah, and then like on a general note, that when we want to introduce a new fuel, would it be hydrogen or something else, there are actually a vast number of matters that we need to address. And if we talk a little bit about how to prioritize these, so safety for people and environment is by far our top priority. So we have to start with the safety system. And when we have a decent understanding of the safety practices to be used, we can start looking at the fuel gas supply system and also the balance of plant. And only after that one we can actually start gearing and starting up our equipment in order to research the combustion itself. And that is a necessary step in order to understand what kind of exhaust gas abatement would be functional and would be also necessary for this particular fuel. And when it comes to the engine itself, so we would mainly then be focusing on the top part of the engine. And now within the coming weeks and months here, we will actually have the first initial results for how hydrogen would work in an engine. And as we heard, especially in Jukka's presentation, it will take a while before there will be green hydrogen at scale available. So we are well in time for this development. Can I have still one slide? And this would actually be my answer to your question. So we also that the internal combustion engine will not by any means resist the change that will be needed in order to decarbonize our planet. It's actually the opposite. With its superior flexibility and efficiency, it is ready to take that challenge. And if we fail, we just fail beautifully, and we have to also look at other technologies. But maybe in the future, not so long from here, we just think that we fuel the engine with water that we can drink. Thank you.
Okay, thank you, Eric. So if we can actually we don't have to bury these diesel engines yet. So could you just not yet. So could you just tell me about the retrofit market? I mean, how big is the global retrofit market? Because okay, this is definitely okay. You're developing engines to new engines towards the hydrogen fuel, and now you have these retrofitting possibilities of the old engines. So how big is the global retrofit market?
That's a really excellent question. And if we look at the deliveries we have made from Wärtsilä, and on top of that one, there are many other players as well that has been active in the marketplace. So we have actually been able to reach a level of 74 gigawatts of engine-based power plants out there. That would actually translate to roughly 12,000 engines in about 5,000 power plants. And how many of these actually eventually would end up converted to hydrogen, that probably remains to be seen when we know how the engine will behave. But definitely there will be other, from a logistics point of view, other fuels available that would be where it would be actually easier to convert. So if we look at, for example, synthetic methane or synthetic methanol, for example, I strongly believe, and in Wärtsilä we believe that the installed base will play a major role in the decarbonization game also.
Do you have any estimation about the time horizon? When is this going to be happening? When you are going to see this retrofitting of these potential engines to be realized? During what time horizon?
Yeah, I think there will actually start happening things in the coming years, and when the availability of the green fuels will be scaled up. I mean, we can already use biofuels, for example, and we already have biofuel installation out there. But probably before we start seeing this kind of big scale hydrogen availability, that will take 10 plus years for sure.
Okay.
But from a technology demonstration point of view, we already have one marine installation that is, for instance, using methanol as the fuel. So we can demonstrate and make sure that the technology works when the fuel becomes available.
Okay, thank you, Eric. This was really clarifying, and since having one of these engines, a couple of these engines in the lab, I mean, I'm really comfortable that hearing that they are not going to be dying anytime soon. Okay, thanks, Jukka, thanks, Eric. So let's move ahead with the webinar, and like Jukka already told, that the hydrogen market has been slowly and gradually evolving during the last decades, and now we are actually talking about a bit more in wider sense what comes to the sustainability and the possible of sustainable transition with hydrogen. So the need and the requirement for this energy production's decarbonization is, however, it needs, however, this kind of large and system level and system scale solutions. So our next speaker is Niko Paaso, and he's coming from the EPV, and he will present a project called HFlex-E, and it is a hydrogen production solution for large-scale hydrogen production. So please, Niko, feel free to start your presentation.
Good afternoon. I will start with a short presentation of EPV Energy. EPV Energy is an electricity generation and transmission company, and we are owned by Finnish municipal energy companies. We have 20 shareholders in total. We have a versatile generation portfolio. We have nuclear, hydro, wind, and CHP in our portfolio. The share of emission-free energy sources in our electricity generation was about 85% in 2020. 44% of the electricity came from renewable sources. In near future, our carbon-free production will continue to increase. Our nuclear production will increase quite much with Olkiluoto 3 coming to production and in beginning of the next year. And we also have several new wind power projects in pipeline. And next we could take the next slide where we have a little bit of our emissions targets. EPV is targeting to be carbon neutral by 2030. And we are on a good path to achieve this challenging target. Here we have a graph of our historical CO2 emissions from electricity generation and how we see that the future forecast goes. We can see a strong decline in emissions since 2011, but there's still some way to go to the zero emissions target. And how are we planning to achieve this target? We will increase the amount of wind and nuclear generation. We will have industrial size solar power generation, and we will also give up fossil fuels in our CHP plants. That was a very short background of EPV and our emission targets, but let's move now to today's subject. The P to X to P system and why we see such huge possibilities there. We strongly believe that the electricity will have a major role in achieving the global carbon neutrality targets. Hydrogen produced with carbon-free electricity will play a key role in this energy transformation, and we believe that there will be a revolution of new electricity, and hydrogen will be in a major role there. To achieve global European and Finnish carbon neutral targets, we will need a massive increase in renewable and carbon-free electricity production. And in Finland we have a great possibility to significantly increase wind production. According to the Finnish Wind Power Association, the Finnish wind production capacity will double in coming 3 years. According to the same source, there are wind projects in planning phase, which would increase the current capacity to 10 times higher level in the future. And if we think about the whole potential we have in Finland, it's most likely even much bigger. So in Finland we have a clear competitive advantage with the possibility to massively increase the amount of wind production and carbon-free electricity generation as such. If we take the next slide, please. Here we have the EPV's future energy system vision. In the center of the vision is zero emissions electricity system, and zero emissions electricity will be produced with wind, solar, nuclear, hydro, and biomass power plants. Electricity will be used to produce heat, hydrogen, and synthetic fuels and heat. Due to this, we believe that the electricity demand will increase a lot, and there will be different solutions for electricity, for different storage solutions for electricity and heat. There will be sector coupling. Industry, transportation, cities, households will be linked. The challenge of having so much renewable electricity production is that we cannot forecast when it will be windy or when the sun will shine. We will need a lot of flexibility in the new power system, and that can be achieved with electricity storages and peak power plants. Hydrogen is seen as an excellent storage solution for renewable electricity in the future. And if we look at the next slide, we have the P2X2P project in Vaasa, which we call the HFLEX-E project, meaning hydrogen flexibility energy. To fulfill these storage and flexibility targets which I described, we are planning to invest in an industrial-sized P2X2P system in Vaasa, and our partners in this project are Wärtsilä, Vaasan Sähkö, and the city of Vaasa. This system would be unique even in global perspective, and the system is very scalable. The system is planned to be built to the same area we already have Vaskiloto CHP plant. So we have the existing infrastructure in place which we can use. And the Vaasa HFLEX-E system can be divided in two parts. We have the power to X part, where we first use electricity to produce hydrogen in an electrolyzer. This is done when there's this is planned to be done when there's a lot of renewable electricity supply in the system, and typically at that time the electricity price would be lower. After that, we compress the hydrogen and store it in a high-pressure hydrogen storage. And then we move to the X to power part. In situation when we have less renewable electricity in our power system, meaning typically in Finland's situation when it's not windy, we reuse the hydrogen which is in the storage to produce electricity with engines. And at those moments, electricity price is assumed to be at a higher level. At the beginning of the development phase, we are able to use 25% hydrogen of the total fuel volume, and the rest will be either biomethane or natural gas. And the goal is to increase the amount of green hydrogen used in energy production step by step, and by 2029 we would have a 100% carbon-free cycle from power to green hydrogen and again back to power. All the excess heat generated in the process will be stored in the Vaskiloto underground heat storage, which is already there available. From the storage, the heat will be used to warm the city of Vaasa. This takes the overall efficiency of the system much higher. And we can also provide hydrogen from the system to local industry and transportation. We can bring together technology development, energy sector, city, transportation and industry. This creates possibilities for carbon neutral transition for the whole Vaasa area. To summarize, we see huge potential in this B to X to P system for power producers. We will get an electricity storage and a way to produce electricity in peak demand situations at a flexible way. At some point of technical development, this can be done totally in a carbon neutral way. With this system, we can produce hydrogen, and we have also the demand side in place, which is also important. The technology is already there. It just needs some further development. Thank you.
All right. Thank you, Nico. Okay, you have really comprehensive concept presented, and in this last image that you are showing now, there's also this heat storage, Vaskiluoto heat storage connected to the whole entity of this concept. And of course, there are already some electricity storage technologies in the market, like batteries or pumped hydro. So how does this H-Flex-E concept complement these already existing storage technologies and solutions? How do you see them, how it will integrate to the technology and as a concept to the already existing ones?
Well, that's true that we have already existing electricity storage methods, and you mentioned pumped hydro storage. That's most likely the most common way of store electricity in the world. But there are also limitations in the pumped hydro storages, because there are limited amount of places where we can build those systems. And typically those systems also have limitations on how much one can store electricity. One other storage solution which is quite popular at the moment is electricity batteries. They are also very interesting from power systems view. They are very fast to react, and they are a very good solution, for example, for frequency control. But the issue is that it's very limited amount of energy or electricity one can store in an electricity battery. Advantage of this hydrogen compared to those two examples is that if we further process hydrogen to e-fuels, then we can really achieve seasonal storages. It makes the limitations to store much smaller.
Okay, thank you, Nico. This is a really nice image what you are showing, but you are showing the concept, but then you are showing like an ecosystem. There's the city of Vaasa, and then there's industry and transport. They're usually the sectors that are thought that are usually said that they are the most difficult ones when it comes to decarbonize and decarbonization. So is this actually like an ecosystem building project as well, not just a technological project or pilot, or also this kind of ecosystem building project?
Yeah, that's a very good question. This H-Flex-E system creates, in fact, possibilities for ecosystems and sector coupling. When we will have hydrogen available in Vaasa area, the local industry, transportation, city can all start to create solutions to utilize the hydrogen. And the hydrogen can also, when it's in place, it cannot be also further processed to e-fuels, and that makes the use of the hydrogen product even easier. And of course, it's much easier to invest or to make investment decisions in technologies which use hydrogen if hydrogen is already there, so if it's available. So yes, it is an ecosystem creation project.
Thank you. And the last question for you, Nico, because okay, there's lots of existing technologies, but in a way, the solution and the concept is quite ambitious and it's very innovative. And for me, it looks like it's going to still need some development work and research, not to mention quite considerable investment. So what kind of funding mechanisms you have found for this kind of innovative project? Because the technological maturity is not in the level of the mainstream technologies. So is there any funding mechanisms there to support this kind of realization?
Yes, that's very true. And the reality is that this project at this point is not economically feasible without subsidies. And if we want to be front runners in hydrogen development, which also gives huge opportunities to Finnish companies, we hope to get funding also from the Finnish government. And in fact, we have applied subsidies from Ministry of Economic Affairs and Employment, but we haven't received any, or it hasn't been decided at this point of time yet. So
okay, thanks,
we are targeting on that subsidy.
Yeah, thank you, and we will keep your thumbs up for you for this funding process, because it certainly is something really interesting to see how it's going to be realized, if it's possible to realize. So, thanks, Nico. Our next speaker and the last speaker is Hans Alexander Öst, coming from Vaasan Sähkö. And Hans Alexander will tell us the company's perspective, energy company's perspective to the Finnish energy markets and the importance of this H-Flex-E concept when energy companies are replacing fossil-based energy production technologies that we've been depending on for centuries now with these zero-emission production technologies. So please, Hans Alexander, go on with your presentation.
Thank you, Sophie. So great to be here. And just a few words about Vaasan Sähkö before we start. So Vaasan Sähkö is a Finnish energy utility company based in Vaasa, founded in Vaasa in 1892. And our core business is electricity retail. And then in Vaasa, we also have district heating. We are in close cooperation with EPV. Our production, energy production, is in EPV, and by that we are also the biggest shareholder in EPV. I will today go into the energy market and our views, why we think this is important. And if we move over to the next slide, we can see that we sure believe in a clean energy future. And this hasn't started today. It has been a long journey, and actually we already started in 1991, being part of the companies that built the first wind power park in Finland. This was in close proximity to Vaasa and consisted about 4 wind turbines. The power levels on those wind turbines were 200 kilowatts each. And if we compare to the ones building today, we are already above 5 megawatt per turbine. So it means that in this time they have been largely developed and 25 times bigger roughly than at that point of time. Today, we are also among the largest wind power producers in Finland together with EPV, and we have, as we speak, 82 wind turbines in operation and 20 other ones under construction. We are investing at this point of time in renewable energy, meaning today wind power. And that is because it's one of the best ways, one of the cheapest ways for us to produce power for the electricity markets. But it's also a requirement from our clients. Our clients demand sustainable solutions for us. We need to be able to provide carbon-free energy. And today wind power is the most sustainable way to do it in Finland. We also think that in future solar power will come to Finland and will be a good complement to wind power. But if we look at, let's take a look at the next slide on how the power generation looks in Finland. And this is a snapshot from last summer, 30th of July, where we can see in very small text that that we have some biomass generation in the bottom, and then we have some fossil gas, some oil, coal in purple, and peat generation. So some small part of fossil generation. The rest is then hydro, nuclear, and wind power. So we could already today say that during summertime we have a very clean energy system in Finland. And at that point of time, on that day, the peak power demand was 6,500 megawatts. If we then look into the next slide and where we can compare how it looks during winter time, we can see that in the bottom we have a yellow part, which is the gas, oil, coal, and peat. And during winter time, this is providing then 2,800 megawatts of power. And this is, of course, especially coal and peat that we want to retire to replace with renewable generation. But at the same time, if we look in the top of the picture where we have the wind power generation, we have at roughly 1 p.m. there's only 197 megawatts of wind power being produced in Finland. And 5 hours later, it has going up fivefolds to 1 gigawatt. This means that, of course, you cannot control, you cannot decide when the wind blows. It is volatile. And if we move over to the next page, we can see some of the challenges that we will face in future. So this is wind power production in Finland in 2020. At that point of time, we had around 2,000 megawatts of wind power capacity. And you can see it's very volatile. It's at certain point of times it's peaking, but it also can be close to zero. And especially during winter time, if we look into the midsection, we can see it's almost all the time below 500 megawatts. This is when we have winter time in Finland and when we need a lot of power, a lot of heat. So this means that we need to have flexible solutions to compensate. It also means that if we want to continue to invest in wind power, we need to find ways how we can transfer this energy. Seasonal transfer, but also maybe from week to week or day to day. If we look into the opportunities how we can store energy on the next slide, we can see that battery energy storage is very good to store energy up to certain hours. It's a fast way. You can go from 0 to 100% in less than a second. It's very fast and you can control, but the amount of energy is not that large. In Vaasa, we also have a huge heat storage, very good for our district heating system, and we can also transfer electricity to the heat storage. But then again, if we want to turn it back to electricity, that's more difficult and not really feasible for that. So from electricity to heat, that's good, and we can heat buildings, but then again, we need to find a way to transfer it back to electricity. And here comes in power to X to power, where we can go into producing clean hydrogen from renewable sources, store it 1 day, 1 week, or even seasonal storage. We could even transfer it to other sources of synthetic gases and compress it. And then when the time is there and we need additional energy, electricity, we can, for example, through a Wärtsilä gas engine, turn it back to electricity. This brings us to HFlex-E on the next page, where we really think that this will help us to optimize and demonstrate how flexible operation can be done with sustainable green hydrogen. And our clear goal is to reach a production with 100% green hydrogen. So we don't want to replace coal and take another fossil fuel. The goal is to go all the way green to 100%. This will also enable and support how we can use renewable and uncontrolled energy production and to move that into flexible energy storage. And the transition to 100% renewable energy is already here today. And we think that HFlex-E project offers a great solution that will support us in this journey together with all our clients. Thank you, Sophie.
Thank you, Hans Alexander, for your presentation. And I have a couple of questions for you also. So Vaasan Sähkö is a local energy company. And now you are there talking about that actually we do need this flexibility in the grid and we need to decarbonize our energy production. So what kind of benefits and opportunities this kind of project and this power to active power, what kind of possibilities it creates in the local and also international levels for the actors? Because like in the Nikos presentation, we saw that this is more like an ecosystem building also. So you as energy companies representatives, what is your opinion on that? What possibilities in the local and national level it will bring to the actors in that ecosystem?
So really to start to go from the goals we have in Finland on national level to reach carbon neutrality. So that means for energy production and especially heat production that we need to find ways how we can store energy, especially how we can transfer part of the energy from summertime to wintertime. In Vaasa, we have an even more ambitious target to reach carbon neutrality during 2020. So before 2030. Part of this plan is to retire fossil fueled generation, which is bringing flexibility to us for the system today. So we need to replace it with other sorts of flexibility, energy storage, and so forth. And this will then be part of, let's say, Vaasa's and Finland's journey towards finding solutions to reach carbon neutrality.
Okay, thank you.
We also think...
yeah, go ahead, please.
Yeah, we also think, of course, that when we are successful in this together then with EPV and Wärtsilä has a great product to go outside of Finland and for the global market and sell these solutions.
When talking about global markets and if we continue on the path we have been and with the fossil fuel consumption, and do you as an energy company representative, do you see that there could be kind of an energy shortage in the future if we don't actually change our production technologies? If we don't do this, if we don't go ahead with the decarbonization in the level that we should, what do you think?
I'm on the same line as Jukka. I think that wind power and solar power being the cheapest ways to produce energy today globally, they will partly solve the problem. But then we also need flexibility in the system. The flexibility can be brought by, for example, energy storage, but it can also be brought among consumers on smart devices. So for example, when do you use your energy, and try to, or let's say, use smart devices to use the energy when there is energy available. and to have automated smart systems that can control and balance the system without interfering with the clients. So that
Okay.
usually you talk about demand management, or when you go into systems like this, and it's being used, for example, in industry already for a long time. But I see clear that that also private consumers are coming into this market, and especially when we start to talk about, for example, e-vehicles, and when do you charge your e-vehicle?
Thank you, Hassi. So if we think about this kind of solutions, what Nico and you have been presenting, so and like Nico in presentations, he said that these are scalable. And when we think about this global need for energy and green energy and increase energy efficiencies and energy accessibility in the developing economies, can you see this as a problem fixer for those economies and countries who are actually now thinking about how to get energy, how to make possible for their citizens to even have a connection to the grid?
Yeah, I think this can have a role, and a lot of supports are being distributed to hydrogen economy and the development of hydrogen economy. So I think this can play a role in solving that kind of problems.
Okay, thank you, Hans Alexander. Now, if I could have all my speakers with me at the same time, because now I'm presenting. This is not over, guys. We are still continuing this. So we have a few more questions for you when you are now here all together. So this is very ambitious system level solution what you have been presenting here. And definitely we all know Wärtsilä, and we all know that Wärtsilä is a company with operating in the global market. And how important you actually consider this as the way and a path for you for this kind of power to X to power global market product development, these kind of pilots, what you are realizing at the moment with this project?
If I answer to that
So
question,
yes, you can.
Yes, definitely. I think that this is extremely important project for us, because at the moment the global market is going through a huge change. There is areas that are extremely developed, like California, Germany. They are taking the steps forward. Then we have still areas in the global scale that are still burning HFO and other extremely non-clean fuels. And with this kind of trends and what is happening, it's extremely important that we have physical location where we can see that this is doable. We are doing this today. So with today's situation, I would have to say that seeing is believing. And here, when we are presenting this kind of a case here for the global markets, it's extremely important.
Okay, thank you, Jukka. And now we have some questions from the audience. So please, here is one coming from Core Pen. So how could the suppliers and existing business ecosystem around Wärtsilä EPV City of Vaasa start to prepare for an increased demand of hydrogen-related know-how? Anyone volunteering to answer this one?
Yeah, I can try at least. I would say that since we are not talking about one single, product or a solution or nothing that would be limited only to Wärtsilä or any of the other, as Nico presented, this is about an ecosystem. And I think that in terms of solution development, we need to think ecosystem level in the future, because previously a power plant, if you take, for example, a power plant that has been built on a business case, and the business case says that, hey, this is the fuel that you will get and for this price. But now when we are actually closing that loop and actually making electricity out of electricity through this hydrogen cycle, there is a massive potential for cooperation within a cluster like we have, for example, here in Vaasa, the energy cluster.
Thank you. And then there is another one. This is mainly, I think, for Eric. So this is for you. So from Tuomo Rinne. What kind of efficiencies are we talking about in hydrogen combustion engine if we compare to fuel cells? And do you see that there is a place for them outside retrofit market in the future?
Yeah, I would say that what we, of course, I must say here at the beginning that we are just standing in front of testing the pure hydrogen concepts, but as far as we estimate for now is that the thermal efficiency of the equipment would be more or less on the same level as we have today on fuel. But of course, considering the combustion properties of a fuel like hydrogen, which is very different to natural gas, the equipment power output would most likely be less. So the power density of the equipment would as such go down. A fuel cell, on the other side, that's a very tempting technology for hydrogen, and it will definitely play a role. Of course, the size scale of fuel cells today are pretty small, but they will be growing for sure. And the let's say the opportunity with the fuel cell is that it works in both directions. It can work as an electrolyzer, but also as the other way around. But of course, there also the limitation in the fuel cell is that if you have a PEM fuel cell, for example, for hydrogen, it will work on hydrogen and nothing else. And the combustion engine as such will of course have a bigger flexibility, because there you can also convert it rather easily to, for example, another synthetic fuel. But the roundabout efficiency, that's of course suffering from that flexibility.
Thank you, Eric. That was a very good answer to that question. So now we are at the end of the webinar. So just to conclude and make the final remarks. And so the need of this decarbonization and it's of our energy production is quite evident, and the hydrogen is showing a great potential of being the solution for the decarbonization, also to the sectors hard to decarbonize, such as industry and shipping, as we saw from the presentations. So by realizing this kind of very bold and ambitious pilot projects like HFLEX-E, we do not only enhance the technological development, but we also enhance the development of societies and economies towards sustainability and carbon neutrality. So we should not only think locally, we should also act locally and realize these pilots. And by doing this, we can certainly have a global impact. Thank you for all listening to the webinar, and let's hoping to see you next year face to face in the Energy Week.